Guys, so today we're going to be learning about the chain rule. So the basic intuition for the chain rule is you're taking composites of two functions. So let's say our first function, right? Let's say f of x. We'll keep it simple for f of x. Let's say it's x to the third, right? Oh my goodness, x to the third. I know it looks weird. X to the third. And then let's say our g of x, right, is, let's make this actually a long function. So let's say it's x squared plus 3x plus 4, right? So basically what the chain rule is it's a composite. So I don't know if you guys remember how to do composites, right? But the basic intuition, there's two ways to write composites, right? There's f of g of x, right? And then there's also f g composite f of x. Well, right? So these are one of the two ways to write them. I'm pretty sure there's another way, but I can't remember. But basically, I like to use this one. So all it's saying is that you have your f of x, right? And you have a g of x. So wherever you see, because it's f of x, right? So when you see an x, you put in that value for that function. So in this case, we have a function, right? So we're going to plug, because g of x is equal to this, right? So we're going to plug this into right here. So if we plug this whole thing into right here, don't we get f of x squared plus 3x plus 4, right? And we said our function f of x is x cubed. So wherever we see an x, we're going to put in all this, right? Because it goes back, so that's a little bit tough to understand. So it's like going back to this, right? Let's say you have a function and you say it's, let's just say 3x, right? And you want to know what so remember when you guys are doing, little tables, x and y, and then you plugged in a 1, and to figure out what that 1 is, you put the 1 in there, right? Well, another way to write it would have been f1 is equal to 3 times 1, right? So that means that f of 1 is equal to 3, or your y itself could be equal to 3, right? Right, so 3. Well, you can't really say y, but y of 1, giving a subnote y of 1, is equal to 3. So it's the same thing here. When I have my function x squared plus 3x plus 4, well, it's not a number, right? It's no longer a number. It's actually a function now that we're plugging into this x cubed. So let's plug this into here, into this function, because that's what composite is, right? So now we're going to have our f gx. So this is the composite of f of x and g of x is going to be, well, we're going to plug this in here. So it's going to be x squared plus 3x plus 4, all this to the third power. So now this is where derivatives kick in. They're telling you take the derivative of this right here. Well, now we have a problem, because now to take the derivative of this, we have to write it 3 times, right? Because that's what the third means. We're going to have to write it 3 times, and we're going to have to distribute everything. Imagine how long that's going to take, and then once you've distributed, you still have to find the common terms and then add them together. Then you finally use the derivative. It's like extremely long, right? But that's where the chain rule comes in handy, because you can take the derivative of this in a couple of seconds. So if we have this, right, this, and we want to take the derivative, that's where the chain rule comes in. Chain rule. So we have this. So the chain rule is just like when you take a regular derivative, except it's a little different. So let me just write this on another piece of paper. Hold on. So when we took the composite of these two functions, okay, when we took the composite of these two functions, we got x squared plus 3x plus 4 to the third power, okay? So it's the same thing that we do when we take a derivative. So what was the steps for taking a regular derivative? It was you get the exponent, you multiply it times the coefficient, right? Well, in this case, our coefficient is 1. So 3 times 1, okay, we're taking the derivative of this. So the derivative of 3 times 1, that's 3. Then we wrote everything exactly the same. So x squared plus 3x plus 4. And then what did we do after we wrote the 3? We subtracted 1 from it, right? So it's going to be this. Well, this right here is just going to be 2, right? So we're not done, right? We're not done. We haven't taken the full derivative yet. So it's going to be 3x squared plus 3x plus 4 to the second power. And now the only difference is that we're going to be using the chain rule. So once you took the derivative of the outside, now you have to take the derivative of the inside. So that means that we took the overall derivative. Now we have to take a derivative inside the parentheses. So except we're not going to add it, we're going to multiply it times our overall result. So now we took the derivative of the outside, now we take the derivative of the inside. Well, what's the derivative of x squared? That's going to be 2x, right? What's the derivative of 3x? Well, that's just going to be 3. The derivative of 4 is 0, so that's it. So this is the derivative of this. So I'm going to do more examples because the chain rule is probably what trips people up a little bit. But you know, we could actually simplify this, right? We can actually distribute this 3 onto here, onto this one, right? Because we can't distribute 3 into here, right? Because there's a squared. So there's no way of distributing that 3, but we could actually have distributed instead. It's x squared plus 3x plus 4 to the second power, then 3 into 2x, that gives us 6x plus 9, right? So that's the derivative. And I think a good idea would be to show you guys a small chain rule example and then actually distribute it and show you that you get the same result. So, okay, so let's say we want to take the derivative of, let's say it's going to be simple, so x plus 2 squared, right? And I'm going to show you using the chain rule and by distributing, then taking the derivative, that we'll get the same answer. So let's take the derivative. So this is the using chain rule. We'll see what we get when we distribute, but chain rule for now. So it's the same thing, remember, as taking a regular derivative, except now your inside is no longer just an x, you know, it's its own function. So what we have to do is we're gonna have 2 times the coefficient. Well, the coefficient is 1, so 2 times 1, that's just 2, right? Then we're gonna write everything again, and then we're gonna write 2 minus 1. Well, that's to the first power, right? Right. And then we're gonna multiply it by the derivative of the inside. Well, it just so happens in this case that the derivative of x is 1, right? Because I don't think we went over that example, but let's see, if we're taking the derivative of x, right? Well, isn't this x actually x to the first power, right? So leading on to believe that to take the derivative, you have to multiply the exponent times the coefficient. Well, the coefficient's not there, but it's actually 1, right? So 1 times 1, that'll give me 1. X to the, right, we're going to subtract 1 from the exponent, so 1 minus 1 is 0. 0 to the first power, well, that's 1. And 1 times 1, that'll give me 1. So the derivative of x is 1. And you know, I know we did this a lot in the other videos, but you know, the derivative of 2x, well, when you're taking a derivative of a linear function, it's just basically the coefficient, you know, 2. And it's the same thing. If I'm taking the derivative of, let's say, negative 3 of x, right? Well, it's just keeping the coefficient, so negative 3, right? And anything linear, as long as it's to the power of 1, the derivative is the coefficient in front of it. Alright, so back to this. So now we have to take the derivative of the inside. So the derivative of x is 1, and the derivative of 2 is 0, so it's just 1. So now this is our derivative. I'm gonna write over this pencil. So 2 times 1, that's just 2, and then x plus 2 to the first power. There's no need to write it. Now we can just distribute this 2x plus 4, right? So this is the derivative that we got using the chain rule. Now we're going to use the linear distribution of derivatives and show that even when you distribute this and create a quadratic equation, that you can still take its derivative and come out with the same answer. So we had x plus 2 squared, so x plus 2 squared. So now separate this. So now I'm gonna actually distribute this. So this is equal to x plus 2 times x plus 2. Right now we just have to use the distributive property or FOIL, right? So this onto this onto this, this onto this, and this onto this. So here we get x times x, that's x squared. X times 2 is going to be 2x, right? So 2x, then 2 times x, that's 2x, then 2 times 2, that's 4. Right here, this becomes 4x, right? So we get x squared plus 4x plus 4. And I'm sure you guys are getting that feeling right now when you compare these two, right? Because we haven't even taken the derivative of this yet. We only simplified it from here to here, right? So now we're going to take the derivative, right? So the derivative of our simplified x plus 2 squared was this. So the derivative of the simplified version would be x squared plus 4x plus 4, right? So again, the derivative is a linear operator, so we can distribute d of dx onto every term inside the parentheses. So the derivative of x squared, that's going to be 2x, right? The derivative of 4x, that's 4. The derivative of 4 is actually 0. So when you look at that, we found the derivative using the chain rule, right? And we got 2x plus 4. Then we distributed, and using the distributive property and the linear operation of derivatives, we got 2x plus 4, and they're the same thing. So basically it would even work. It would even work when you have, you know, x plus 2 to the 5th power, you know? Just imagine how long it would take for you to expand that and to distribute all the x's, all the 2's. It would take forever, and then to finally take the derivative. No, but in the chain rule, you know, 5 times the function, right? X plus 2, subtract 1 to the 4th, right? Then all you do is take the derivative of the inside. Well, the derivative of x plus 2, well, that's just 1, right? So this is actually the derivative. So the derivative is 5x plus 2 to the 4th. So from here, we took the derivative, and we got this 5x plus 2 to the 4th. See? And it actually would have simplified having to take the derivative of everything, right? So that's basically it for the chain rule, guys.